Research and Consultancy, Karunya University, to occupy the stage. I request Sri Deepak Varshni, Regional Researcher, International Water Management Institute, India, to come onto the stage. I welcome Dr. Tejal Kanitkar, Associate Professor, Indira Gandhi Institute of Development Research, Mumbai, to come onto the stage. Madam, welcome. I welcome Sri Ravindra Kadam, Senior Advisor, Renewable Energy, CERC. I welcome Dr. Rahul Tongia, Senior Fellow, Center for Social and Economic Progress. I welcome the guests and also a hearty welcome to all of you, the dais and the audience, which comprise of eminent persons, including senior IAS officers, chief engineers, researchers, and public policy persons. I request Dr. K. Ravi, the moderator of the session, to open the session by saying a few words. We can.
Dear fellow participants, thanks for joining the session. Well, I must be asking a very simple question to those who have come from outside Kerala. How's the weather? How do you find the weather here? Wonderful. Thank you so much. It's temperate, semi-equatorial climate, and that makes a difference. Temperate, semi-equatorial climate, that makes a difference. In most other parts, you find that monsoon tropical. You have this, what is called long, dry sort of things. And when you get rain, it is heavy, short period and like that. But in Kerala, the southwest monsoon brings you more rainfall, exceptionally high rainfall. And if you combine this with the kind of geography that we have, it's a mountainous geography. I'm not sure how many of you are so familiar with this. You'll find a very different, unique climate. So you get more water per head in Kerala than other parts of India. You get more water per head in Kerala than other parts of India. We are very rich in water resources, but that doesn't mean that we are not suffering from the scarcity of water. We suffer from the scarcity of water because rapid runoff, absence of storage facilities, and also lack of what is called groundwater recharging and like that. That's with respect to water. And how about power? Power, I tell you that this is the first state in India where we have been successful in distributing power to almost all households in the state. We call it as total household electrification. Total household electrification that was done in 2017. And we continue to improve our what is called the power resources, apart from the fact that we rely on hydel power, say 52 to 60%, we continue to enhance the what is called other sources of power, thermal, solar, wind, and like that. So we have a very different sort of a plan for power sector as well. That means, of course, we have dependency, we have supply constraints. Unlike the case of water, in power we have the supply constraints, but we still manage and we continue to improve what is called the non-fossil fuel energy sources, renewable energy sources. So this discussion is going to be on these two things, power and water sources. We want you to tell us how we should think, for our future development projects. Because you all know that I came to understand that in the earlier discussion you have had something on AI and like that. I was chairing another session, so I was told that there was a session on AI. What does it mean? That means that you need more and uninterrupted power supply. But sadly, we don't have that much power supply to provide for setting up AI sort of data centers. But still, we could manage, we could plan for that. What I'm trying to say is that, as and when we progress towards 2031, as Nagesh has rightly pointed out, the 75th year of state formation, we really wanted to set up the AI data center or other kinds of infrastructure facilities and like that. So this discussion is going to be about the power and supply, and we want the speakers, we would expect the speakers to enlighten us, saying directly to us, look, you please go for this, you please do this, so that you can address the likely challenges that are supposed to emerge as part of our pathways to future development. So we have 6 speakers, and I would say that each speaker can take 18 to 20 minutes maximum. And once the presentations are over, we'll open the theme for discussion, and then we'll request our chief, 2 additional secretaries here, Sri Bishwanath Sinha and Puneet Kumar, to summarize what the speakers have said, and also by picking up some critical insights from the audience, I would expect them to summarize the whole discussion. So is that okay if I invite Dr. A.K. Gozain, Professor Emeritus from Indian Institute of Technology? Thank you so much, sir.
A very good afternoon, dignitaries on the dais and off the dais, all the participants. I'm really impressed with the intent the state of Kerala is having in giving vision to the 2031. I've gone through the document, the vision document, talking about the water resources. Being a person from the water resources area, I'm going to stress more on that aspect. I feel they have looked after all the important aspects in terms of what needs to be done, what are the issues around water as far as this state is concerned. And if all that is put into practice, I don't think that there'll be many of the problems which will be left behind, they'll be taken care of. But at the same time, with respect to my experience, what we have been experiencing while handling this very important but very difficult sector of water resources, which is becoming more and more complex, I'll try to focus on some issues with the request if they can be considered as additional issues which can be looked at while finalizing this vision document for 2031. I'll try to skip some of the things which I feel everybody knows, that why energy and water matters for Kerala. Because of the limited land, we all are aware of that, and the ecological sensitivity. Being part of the Western Ghats, these are the most sensitive area of our country, and we have to handle it very carefully. And it interacts with water very closely. But on top of that, the high climate vulnerability, not of the past as such, because we have been saying for the this area of Kerala, the vulnerability has been there, and we have been getting abundant water. We have around 3,000 millimeter plus rain, which anybody looking at that will say that what more you need. But it's the distribution which is important. And that is true for our monsoon. We get most of the water concentrated in 4 months. And on the contrary, when you get so much water in such a less time, that can turn into floods. And then whenever there is a bad year, because this water is not guaranteed. It depends on the monsoon, how the monsoon proceeds, that how much of that you will be getting. And if there is a bad year, then you have another extreme situation of droughts, which can hit you very badly as agriculturists or even other usage, because you have not much storage is available. And with the rising development aspirations, which every state has, and I'm very happy to see that the kind of aspiration for their masses the Kerala government is having inclusive development, not leaving anybody behind. That is the intent which is very well placed, but with that intent, your demands also become higher and higher. So we have been discussing and we have been going through the material which has been made available to us, that Kerala is trying to put the best foot forward with these basic intents. And if it has to be taken care of properly, then you need an integrated approach, which is science-driven and especially concentrated on the resource management. And I'm going to discuss more on the water resources. So the uneven spatial and temporal distribution can be a major problem, which is going to exacerbate further because of the climate change implications. See, for the whole country, the major climate change implications, which we are studying since the last 20 odd years, that your volume of precipitation might remain similar, but the distribution is going to go haywire. What it means is that in the conventional way, if your number of rainy days, which were some number of rainy days, average rainy days over the monsoon months, they are going to decrease. If the number of rainy days are going to decrease, the kind of implication it has is that your gap between the two rainfalls is going to increase. And since still we have majority of the agriculture area is under rain-fed agriculture, we have not been able to provide the irrigation facilities to the whole area which is put under agriculture. So these areas which don't have the irrigation facilities and the duration between the two rainfall is going to be higher, that it cannot survive on the basis of the soil moisture which gets accumulated in the soil because of the rain coming. Your rain-fed agriculture is not going to be sufficient to make the crops survive. So there'll be implications to the crops. Your yields will become low, and in some cases the crops might also fail. So even those areas where you are having the kharif crops under rain-fed agriculture, if they are going to be impacted, you can only make them survive if you have a supplementary irrigation available, for which you need the infrastructure. You need the more storages for irrigation. So under the climate change, this is one possibility which is going to be faced, and we have to have mechanisms put in place where such situations can be tackled. And the infrastructure, whatever infrastructure we have for irrigation or for other situations, I'll talk about anything which is connected with water. When you talk of the rural areas, irrigation is a major infrastructure which is needed. But at the same time, when you are talking about the urban areas and you're talking about flooding, then the infrastructure is in terms of your drainage infrastructure. So the kind of infrastructure can be different for different perspectives. And you need to modernize your infrastructure because the amount of water will remain, even if it remains similar under the climate change situation. Your requirement, your demand is going to increase because of the implications of the climate change. That means you will have to have additional storages, that is one part, but the existing storages have to be managed properly. Your irrigation efficiency has to increase, which means that with the same amount of water, see, presently most of our irrigation systems, they are running at an efficiency of around 30 to 35%. So that means the utilizable water or the water which is actually producing your crops is only 30 to 35%. The remaining water is lost in various ways, either in going to the ground as recharge or getting evaporated or getting lost in some way. And if you want to enhance your irrigation efficiency, you might have to change the method of irrigation. Your irrigation method presently is flooding, so you might have to go in for sprinkler or drip, which can give you efficiency of around 60% to 65%. So that means with the same amount of water, you can increase your irrigation area or the irrigated area, the command area, to almost a level which is almost double. Or you can say that I have reduced my irrigation requirement by half. Both ways is beneficial to you because this resource is not going to increase. Under climate change, yes, it might be some areas might be getting more rainfall, but that is something can be also more problematic. And the other aspects which you'll have to look at, which is already put, all these things what I'm saying, they're already put in the vision document. I have seen that. And I'm just going to really re-emphasize those aspects that they have to be done, and that is a good investment. So reassessing large and medium irrigation projects. So that means unless you find out what are the present efficiencies of your systems in terms of the irrigation, you cannot take the step of making some interventions and doing something. So the first requirement is to have a mechanism available where you can assess your existing efficiencies or the performance of your systems. You can also add to that various ways, reducing one I have said that's change the method of irrigation, but you can also reduce the conveyance losses. Then one aspect which is beyond these modernization of various infrastructure, and I'll also add to that when it comes to your domestic water systems, how you can reduce the non-revenue water, the leakages in your distribution systems. That's one way of enhancing your or doing the demand management. The other aspects which can also be added in the case of urban areas is how you are handling your wastewater. are you in a position to really reuse your wastewater? Because by doing that, you're reducing your demand. So I think ultimately everything boils down to that you have this much amount of water which is available to you for your state or for your various river basins, and you have to manage within that. If your demand is increasing, then what we have been doing so far, which is reflected in, I think, the whole country, that every basin which we have looked at, we have analyzed, we find that the groundwater table is going down year after year. So what does that mean? It implies that your demand is more than what your availability is. So whatever your availability, you have a deficit which is created because of your higher demand, and you are going to basically take that deficit from the groundwater, and with the result, your water table is falling down year after year. So you have to arrest that, and that's important for you to take care of. The decentralized water security will also give you the resilience in terms of how you can take care of your earlier systems which were in place, whether it's water bodies, whether it's ponds, or whether it's wetlands. They were performing their own function, the functions around the environmental services which they were giving. So you have to take care of them, revive those whenever is possible. I'm trying to give one suggestion here, because I think if I look at any city in our country, our major problem is that most of the drainage system, which is the natural drains, in every city has its own natural drains and water bodies, they're all polluted because we have not been able to tackle our wastewater properly. So whatever you think of is going to take us a lot of time, even with the good intent, to segregate the wastewater or the sewage from the stormwater. In most of the cities, the two are getting mixed, and we have to find ways and mechanisms, because to put this infrastructure, it might take us another 10 years. Every city is grappling with that, and we are finding that is not happening. So we have to find solutions which can provide you a mechanism to really take care of the wastewater and how to clean that water by having non-invasive mechanisms or methods. Because if you are to create an infrastructure and after that you are creating the total sewerage network where the segregation is done, then whatever you have invested in now is going to go waste. So for this, the transitional period, you have to find solutions, and we have recently found, and we have made a consortium of some of the IITs and some industries put together to look at their nanobubble technology, which has been proven to be a very useful technology in this direction. So I'll recommend that even in this vision document, for such periods till you are completely in a position to segregate the wastewater properly, we should encourage this, because it is just a benign thing. You're only creating the nanobubbles, which are basically having the air inside, the oxygen inside, and then it takes care of the pollutants, and it settles on the bed of the drain or the water body, and it has been proven to be quite an effective way of doing this management. Then the other thing I think I wanted to lay emphasis on, that when you are looking at the monitoring of this particular water resources, as we have said that we will be putting the models together, we have to have the infrastructure built and create the digital twins of your natural systems, the river basins, which we already have done At IIT Delhi, we have the digital twins of all the basins at a macro level. But that is not the end in itself. And that is what we are using in the form of making the real-time early warning system using the rainfall forecast of IMD. So we are in a position to tell that in advance how much inflow is going to come to a reservoir. So had that been in place in Kerala, the last flood which was there, it could have been moderated to a very good level. We cannot wish away the floods, but you can moderate them properly. So if you had good enough time, around 3-4 days time, to release the water at a rate which is not flooding the downstream areas, then you can save those areas from the flooding. So I think those things are important, but the scales are an issue. You have things at the local scale, which we are talking about, that the micro watershed, you will try to capture all the information. So that information capture is important. And then its aggregation is also important. So you have mechanism, you have to have frameworks which are GIS based, where you can do the modeling. You can look at how much is the flow going to be generated depending on the precipitation available with respect to the land use. But you have to incorporate all the man-made interventions, which is the most difficult task, because unless you bring that into the model, that how you are operating your reservoirs and how much water is being used, the hydrology cannot be replicated properly. So that is the important aspect which you might have to take care of in this vision document, in terms of having models which are not only talking about the surface water in isolation, but looking at the surface water, groundwater interaction as well. So we are adding the groundwater models to the surface water models, and then trying to look at what is the relationship or how the surface water, groundwater interact. The moment your water tables are going down, many of your rivers might start losing water to the groundwater, because this is a reversal of some natural process. Normally the water table, higher water table after the monsoon, they contribute to the river as base flow. So I think we can only get these informations properly documented and properly put in place. And this is the starting point of your negotiations with the stakeholders. The stakeholders to be given the proper information, what is happening, what is presently happening. And then the modeling environment is very ripe in terms of generating scenarios for the future. What kind of scenarios you have to put in place, what changes you want, and without implementing, if you can showcase to the stakeholders that these are the 4 options we are giving you. If you use this option, this is the implication. If you use the other option, then the implication will change. And that's the only way to create a healthy discussion around the stakeholders and come out with a consensus. So I think these infrastructure, the digital infrastructure, will help you a lot in terms of taking everybody along, showcasing to them what is the ground reality and what changes we are trying to make on ground, which will benefit everybody, and showcasing through the simulation process. That is possible with the present day technologies and with the present day the models becoming ripe and good enough to really believe those outputs. And we keep on validating those outputs also. The other thing which will also happen is that with these kind of infrastructure, the modeling infrastructure, you can do the floodplain zoning. Many a times the rivers, we don't know that, I'm going to stop. Many a times you don't know how much is the portion of the river which is going to be inundated under a particular flood. So if you do this exercise, these exercises, you will know that what are the bylaws, what are the rules and regulations which will feed into your policy making, which are the areas not to be touched in the floodplain, which are the areas which can be used for some issues, it can be much easier to have those clarifications. So I think this is one site which we have developed for the river basins of the country. Anybody wants to have a look at that. And this is a first cut kind of model base which is available, and we can share with the state of Kerala for their area if they want. And I'll stop here with the final conclusion that scientific management is essential and not optional. Kerala can lead with innovation and evidence-based governance, which I have seen over the last day and since morning, that they are doing a wonderful job. And I'm sure that they can create a model of governance for the country to imbibe. Thank you much.
Thanks, Professor Gosain. No, Nagesh, in fact, I forgot to mention that Professor Gosain was very helpful, for making some assessments for what is called Mullaperiyar Dam or Vambanad Lake and like that. Sorry, I didn't mention that earlier. So he has always been helpful for the government of Kerala and for other agencies as well. Thank you so much.
Thanks for reminding us, sir. Dr. A.K. Gosain is a professor emeritus, as I told, in the IIT Delhi and a leading expert in water resources engineering. His work has significantly influenced hydrology, water resources systems, and sustainable water management. Thank you, sir, for your resourceful speech. Now, I invite Professor E.J. James, who is the Pro Vice Chancellor for Research and Consultancy at Karunya University, Kerala. He is a renowned wetland hydrologist specializing in hydrology and integrated water resource management with over 3 decades of service at CWRDM. Sir, welcome.
Thank you, Nagesh. Heavy lunch lulls me to sleep. I'm telling you the fact, with all said and done. And how many of you are feeling sleepy? I'm not sure. That's left to you. Anyway, moderator, additional chief secretaries to government of Kerala, distinguished delegates. Since the moderator has said that 18 to 20 minutes, I thought that I will try to answer 4 questions which are relevant in the context of water management of Kerala. Question number 1. What are the distinguishing factors in hydrology, ecology, and socioeconomy with special reference to Kerala? And if you think that there are certain distinctive factors, features like that, shall we have a paradigm shift in the water management of Kerala? The second question is, we are following the water management which has been formulated by the British for the arid and semi-arid regions, put on us by the present government, and all our sanctions and approvals are based on that. Shall Kerala not have a specific water management practice which fits into the wet, humid tropical climate of Kerala? This is a question to be answered by us. Second question I said 4 questions, but there are some secondary questions, that's why. Second question is, what shall we do? What technologies we should follow to manage the water resources of Kerala? The first and foremost, I'll say, we should go for integrated water resources management as enunciated at the Dublin Conference, Gosainji, Dublin Conference, and supported by the Earth Summit in Rio. Second is that Kerala should adopt Water 4.0 tools for water management. It has not yet come. I attended the meeting of the digital group in the morning. They have never told me anything about application of Water 4.0 for water management in Kerala. Third, Kerala should go for, I feel, river basin approach in planning and management of its water resources. These are some of the things which I'll discuss a little later. The third question is, can Kerala exploit the entire, or harness, not exploit, harness the entire hydropower potential of the state? I made a rough calculation. We have got about 1,500 to 2,000 megawatt more power which we can harness. And this goes in line with the national determined contributions of India for the controlling the climate change, and also it will help us in controlling floods and having sufficient water downstream for the downstream ecosystems, whatever we call as the wetlands. Now, the fourth question is Kerala ready with a vision statement for 2031? Yes. The planning board had constituted a committee with me as chairman to look into it, and we are ready with the document for 2031. I'll present it shortly here. I don't know whether I have permission, Nagesh, to do that. Anyway, permission or no permission, I'm not in the government. Okay, now, earlier I was. So now from this, we go now to answer these questions. What is, I don't have the, it's here. Nagesh, can you just help me? Here we go. As far as Kerala's distribution of rainfall is concerned, we have spatial and temporal distribution of rainfall is not at all uniform. For example, southwest monsoon, if you have got more rainfall in the north and less rainfall in the south, in the northeast monsoon, you have got just the reverse. South has more rainfall and north has got less rainfall. While the eastern portion of Kerala has got more rainfall, the western coastal belt has got less rainfall. Eastern portion is having more rainfall, mainly because of the orographic effect of topography. Somebody was telling about it. And when Silent Valley records almost 10,000 millimeters of rainfall, just 10 kilometers from there, Attapadi records 400 millimeters of rainfall. And when Neriamangalam and other places in Idukki district records 5,000 to 6,000 millimeters of rainfall, you got just 400 millimeters of rainfall in Idukki at Vattavada. So this is something which is to be, and the number of rainy days have gone down considerably from the beginning of this century. Now, the problem with Kerala again is you have got short, steep monsoon flood rivers. When I say short, Manjeshwar River is just 16 kilometers in length. I call it a chale, not a river. Why? Central Water Commission says that the major rivers are ones which have got a basin area of 20,000 square kilometer and more. We don't have any such stuff in Kerala, sorry. We have only 4 medium-sized rivers between 2,000 and 20,000 square kilometers. Those are Pamba, Periyar, Bharatapuzha, and Chalya. All the other rivers, I'll say, are just small channels flowing with water during the monsoon season. That's all what we have. And if you talk about the steepness of the rivers of Kerala, Kerala falls from 2,000 to 3,000 meters to zero within an average width of 70 kilometers. You can imagine how steep we are. So where will the rainwater remain after a rain? This is something which you have to think of. Now, if you think of the topography of Kerala, it's mainly because of this type of topography we have got orographic rainfall, where mountains play a major role in the rainfall, and moisture pregnant clouds escape through the Palghat Gap and the Shangota Gap. Therefore, we have got less rainfall in some areas of Palghat and some areas closer to Shangota. Now, population is a major problem which makes the utilizable water in Kerala less, because we don't have space to make use of our water. So the potential is much less in Kerala. And if you look at Kerala, 54.7% in the highland. Highland has got more potential than the midland. And 54.7% of our highland is forest, where we cannot have larger dams the way the other states in India has. And at the bottom, you have got the coastal wetlands, Vambanad backwater, cold wetlands and all that, which are to be fed with water if the biodiversity will have to remain there. So we have to have more e-water, you want to say e-flows, than any other state in the country. Now, if you look at 2018 flood, 8 districts were under red alert. And if you look at 2019 floods, on the right-hand side, you got in blue, you got August 8th to August 15th, the figures there. How much water has flooded the plains of Kerala? Now, please remember, don't say that Kerala has got abundant water. People say 3,000 millimeters. I don't contribute to it. I'll tell you, Achengovil River, which is flowing into Vembanad, and Meenachil River, which is flowing into Vembanad, are on the verge of acute water scarcity. When I say acute water scarcity, 1,000 cubic meter of water, 1,000 cubic meters of million cubic meters of water, if you don't have, it is supposed to be, I have given the World Bank classification there. It is supposed to be water scarcity, and if it is less than 1,700, it is water stress. So we have got water stress. See those histograph which show the flows to Vembanad. Except for Pamba, all other rivers are practically dry during the summer. And how will the Vembanad backwater survive in future? That is a question to be answered by this group here. Now, this is the groundwater potential of Kerala. Using machine learning, we try to find out what is the water quality index of groundwater and the risk factor. And you got one taluk block in Kerala which is classified as overexploited groundwater, and 2 under critical, and 19 under semi-critical, and the remaining are safe. We can use it if you want to use it. Now, if you look at it, interbasin transfers to the neighboring states have created problem with regard to Periyar. There is a scarcity of water in the downstream reaches of Periyar, and we have diverted waters from Periyar, Chalakudi, and Bharatapuzha to Tamil Nadu under Pamba Changovil project. All these create problem for Kerala. We have to have a real look, Secretary Saab, to the interstate agreements. Forget about it. Now we come to what shall we do about it. I feel that we should go for integrated water resources management as enunciated at the Dublin Conference, a systematic process promoting the coordinated development and management of water, land, and other related resources. It aims to maximize social and economic welfare equitably without compromising the vital ecosystem sustainability. It replaces the fragmented single sector water management with a holistic cross-sectoral process. If you look at it, you have seen the pathways of water management here. Sustainable development. We will have to start from the present situation of single sector to sustainable development for water environment, for which you should have a single function investment, should go to asset management planning, and then to catchment management planning, land use planning, and integrated catchment planning. To come to that, we will have to go through those arcs. Arcs are environmental impact assessment, economic tools, and pressure groups, and strategic environmental assessment. All these are needed. If you look at it, this is how we should go for a basin management plan. Yeah, I'll go faster. I'll go faster, moderator. You see, intra-basin transfer should be attempted in Kerala. This is what I'm saying. Not interstate transfer, intra-state transfer. We should try in Kerala. You've got a model here. This came out of the Rio conference. You see, the functions of, this is the Mekong River Commission. See the functions: agriculture and irrigation, climate change, fisheries, flood and drought. All these come under the functions of the, and you have got also the functions of the commission. Now, this is the organizational chart of Mekong River Commission. Can we not have an all Kerala commission for governance? I think governance is a major problem. Institutional mechanisms will have to improve with regard to whether it is electricity, whether it is irrigation, whether it is drinking water. All these will have to be put together, I have a feeling. Now, we can have a state level system. On the left-hand side, you've got a river basin council at the apex body. We can have a district level system. You can have a panchayat level system. In all these, the block panchayats, the gram panchayats, all of them can participate and can have a stakeholder group to manage the water resources of the state. Now, I just wanted to tell you, I'm going to give you the blueprint of what we have to do up to 2031. I'll go fast, okay? Nagesh, don't get worried. 2 minutes you give me, I'll finish up. Have a look at it. You got, I have given one cluster, a cluster of rivers falling into the Vembanad backwater. You see the hectareage of and total amount, and you have got basin wise, you have got cluster wise. Now see here, I have given a budget provision. Can we have during 5 years 16,000 crores rupees? Give it, we'll do it. If we want to do it, we can do it. We have got a total plan for Kerala. Now see, we have converted into maps. This is the existing projects and the proposed projects and ongoing projects for Bharatapuzha you have here. Like this, we have got for all the 44 rivers, we have got a master plan. Now, why hydroelectric? If you ask me from the Kerala point of view, 4 things I'll have to say. If there is a hydroelectric project, we go well with the NDC of government of Modi ji had promised it with Paris. When he went to Paris, he had promised it. So we will do it in Kerala. Second, Sir, I am not in government. Second, uh, what we have to do is that these structures will help us in flood control if it is properly managed using Water 4.0. It is here where you should have sensors, you should have IoT, you should have AI directed way of operating the reservoirs and regulators of Tanirmukam barrage and other regulators. So these are the advantages of that. You have got the hydroelectric projects for Kerala, which are proposed, which are ongoing for Kerala. Some of them are difficult ones, not prioritized because those are difficult ones. And you have got the flood protection, flood control hydroelectric power generation projects also here. And there is a budget also given that. Third, this is Chalakudi River with the hydroelectric project as well as the irrigation projects. Sir, I was talking about the hydroelectric projects here. We have got a total plan in consultation with the KSCBL. We had prepared that. I'm closing. Maybe I'm in the last one. Oh yeah, that's what you wanted. I don't want to take 2 minutes. Now from here we move to 2031 to achieve sustainable development of water resources in Kerala. Thank you. Thank you very much. Nagesh, you had given me 5 minutes. I did not take 5 minutes.
Thank you, Professor E.J. James. Sir, can I announce this? Okay. Now, we have the regional researcher from IWMI India, Dr. Deepak Varshni. He's an eminent person, an able researcher who has published vastly. I request Dr. Deepak Varshni to come.
So good afternoon, everyone. So first of all, warm greetings to the dignitaries sitting on the dais and off the dais. So today I'm going to present insights from ME's work on reimagining irrigation in India through solar energy. So what this presentation cover to provide some insights based on the field experiments, policy pilots, and large scale implementation experience within India's water energy food nexus. So here I'll talk about two key innovations. One is the grid connected solar irrigation pumps, and their idea is, and I will talk there about the efficiency and the incentives and how these incentives led to the water irrigation efficiency in the agriculture sector. And second is on the community-based solar irrigation adoption. So our message is simple. Solar irrigation is not a technology itself, but if you look from the broader perspective, right? So it is an institutional and economic reforms that can help farmers to improve incomes, reduced financial burden on discoms, groundwater sustainability, and address climate-related challenges. So, yeah. How can I? Yeah, sorry. Yeah. So, right, so this is a brief on India's water-related challenges. As you know, India is a 4% of the world's fresh water resources are in India and 2% of the world's land, but the population, 18% of global human population. So you can see and imagine the challenges we had on the table. And if you look from the climate perspective, it is impacting hydrology and increasing water demand. And as such, 70 million hectares of farmland affected due to floods, and droughts, increasing water risk due to climate change. And there is a recent study that estimated because of this climate related issues, there is a reduction in 6 to 25% of productivity in the upcoming decades. So here, right, so I'll briefly talk about the water, energy, food nexus. So as we know, India's food security gains were historically built on groundwater irrigation, powered by subsidized electricity. And this created a tightly coupled systems under stress, like for instance, right, so if you just give free subsidized power to the farmer, so I'm just speaking in economic terms, for him or her, the marginal cost of pumping for them is zero. So there is a chance they can use this water in a in an inefficient manner. So it creates massive fiscal burden for the distribution discoms, rising power demand. So those are the kind of water, energy, and the food linkages we are talking about. So here, right, so here we come up with the opportunity. Solar irrigation can address decarbonization, water use efficiency, farmer resilience, if the deployment models with the right with the right incentives. So now I'll talk about this first innovation. This is a grid connected SIP. IMMI has first this small field experiment in Dhundi in Gujarat, where we have developed this proof of concept, and then we have implement this small pilot with forming a cooperative of 7 farmers in collaboration of this MGVCL, a discom company. So here the unique idea of this model is that it gives farmers an opportunity to sell excess electricity to the grid at a predetermined tariff and evacuation based incentives, and hence augment their income. So following this pilot, government of Gujarat has launched a larger pilot covering 4,500 farmers, where farmers can get solar irrigation converting their existing electric pumps. And although PM Kusum has also adopted this under their component C, where they have provided this individual grid connected SIPs, but most of the states have not adopted that. So there are a couple of them. UP, Kerala have implemented around 2,500 somewhere individual grid connected SIPs here. So if you just look at the financial model of this grid connect SIP, right? So why I'm giving this much detail is just to understand the mechanics, why and how it improves the water use efficiency, in particular in agriculture. And whether, because you know solar is a costly technology, so, and we are living in a country where more than 80% farmers are small and marginal, and they have a credit constraints, they have a poor awareness, so there are many constraints for this costly technology to adopt. So in Gujarat, this is a Sky model, right? So the upfront cost was 5%, 30% was central subsidy, and 65% is the loan that is taken by the government of Gujarat on behalf of farmers. So the farmers has to don't go for banks for their loans. So government of Gujarat taken on their behalf. And one important thing here I would like to highlight is the incentive is feed-in tariff, INR 3.5 per unit, and plus evacuation based incentive 3.5. So if farmer evacuate 1 unit of energy to the grid, they will get in return INR 7 per unit. So, right, so just think from the farmer's point of view, now they have an opportunity to sell electricity back to the grid, and they can also use this electricity on their agriculture production frontier. So they can outweigh whether the marginal product of energy putting in agriculture production frontier is greater than marginal productivity of marginal returns from by selling this energy to the grid. So if the marginal returns for selling energy to the grid is higher, they can save energy. If they are getting higher returns in putting the same energy in the agriculture production frontier, so they can use more energy in the agricultural cases. Right, so here are some adoption dynamics and economic impact. Like I said, solar is a costly technology, so there are barriers. Farmers are initially hesitant, so they are risk averse to capital constraints, intra-household decisions. But if you look at the drivers, right, so the key drivers are education levels, awareness, pump size, so on and so forth. But the economic impact is large. So these are the results from the Gujarat, from this Sky study, right? So that covers 4,500 farmers. So the farmers who adopted this grid-connected solar irrigation pump have an income enhancement of rupees to 21,900 per year, just from electricity sales, and that is equivalent to 43% of their crop income. And if you just look from the financial feasibility point of view, the return on investment is very high. The total investment that has been done in terms of subsidy by the state government and the central government, payback is 8 years, right? So just by saving the agricultural subsidies. So the green trade-off, like I said, right, so on the right-hand side, I've just put one graph, right, so where you can see the first vertical line is the feed-in tariff for INR 3.5. The other vertical line is evacuation-based incentives. So most farmers in Western Gujarat have a marginal return from agriculture production frontier is less than what they sell if they use the same energy to the grid. And in terms of carbon abatement effects, the impacts are larger, right? So in particular, this grid-connected SIPs on an average offset 11 metric tons of CO2 per farmer annually. That is twice the impact of off-grid solar pumps. Right, so, and like I said, already discussed the economic argument about this model is, right, so the total government cost is around 1.7 million. And if you look at the cost of supply to the agriculture sector, if you take at the rate of rupees 6 per unit, so your saving would be 385 million. And if you take 7.40 per unit, then your saving would be 475 million, right? So just because you are reducing farmers, because now farmers are generating their own energy through solar pumps, right? So in terms of way forward for Kerala, right? So we have started some work in the state of Rajasthan and UP by using these grid-connected SIPs, starting proof of concept, feederizing 2 feeders in every state. So we may request government of Kerala as well, if they, because they have already done this individual pump solarization under PM Kusum C1, so they can take that forward. Because I would like to emphasize here that the other models of solar, like off-grid SIPs or feeder level solarization, have their own limitation, right? So for instance, in case of off-grid SIPs, they are not right, so they are not good in terms of the groundwater thing, right? So because in off-grid SIP, the marginal cost of pumping is 0, and the global evidence and the evidence available in India clearly tells us, right, so it will increase the groundwater extraction. And in case of feeder level solarization, that's a status quo kind of thing. So the effect on the groundwater is dependent on the electricity, the quality of electricity supply, and the daytime power. So that's the empirical evidence related to that is still not there. But in case of grid-connected SIP, the evidence is there, a clear-cut evidence on improving irrigation efficiency and increasing farmer income, climate mitigation. So those things are there. So we can try and test those models in the local conditions and see how they can fit best in the current context. Right, so the second model I would like to speak on the community-based adoption, right? So we have piloted 2 community-based models in Madhya Pradesh, right? So one where we have, it's a earn first, pay later model. So all the 100% project cost is coming from the donor funds, and there the idea is to, because these pilots we have implemented in collaboration with, in partnership with the state rural livelihood missions, right? So because their self-help groups are already there, so we have made those water user associations. So we have also leveraged the fund from the cash credit limit from the SRLM funds. And the idea there is to reduce the upfront cost for each farmer, because now 10 to 15 farmers are adopting a single solar pumps for addressing their irrigation related issues. And so these are the women-led water user associations and self-help groups. And outcomes are really strong, right? So because now women, when we piloted these models in Madhya Pradesh, that's what's happened. They are earlier reluctant to take all those loans and all those things. But now after these models, they are coming forward and getting connected to the financial system. So, and we have also implemented this solar rice mill attached with the solar irrigation pump, so that the unused energy could be used. So, and it is affecting crop choices and profit margins, like crop diversification shift towards wheat during Rabi 2024, and area expansion under irrigation in summer season. Earlier, they were not able to cultivate the summer crops, and profit and revenue enhancement. They have lowered the irrigation cost, plus new revenue from selling water. So this is my final slide. So here I have summarized our learnings from the ground, like SIPs remain subsidy driven. Targeted innovations in subsidy design are essential. So strong alignment needed between agriculture and SIP governing institutions, for instance, power and the water sector. And the way forward for grid-connected solar irrigation lies in getting prices right? So how to set those feed-in tariff and evacuation-based incentives, so that farmers can see and decide how much water they would like to use on their agriculture production system, or how much they would like to use and how much they would like to sell back to the grid. So I think I'll stop here. Thank you.
Moderator. Thank you, Dr. Deepak Varshni, for that speech. Dr. Tejal Kanitkar is an associate professor of the IGIDR Mumbai, working on energy, climate policy, sustainable development. Her research focuses on energy development and climate policy with an emphasis on integrating scientific and social perspectives to advance equitable responses to climate change. I welcome Dr. Tejal Kanitkar for making a presentation.
So let me start off by thanking the planning board for the invitation. It's always a pleasure to be in Kerala. Those coming from Bangalore, however, might have some dispute about whether the weather is better here or not. But I must say the food definitely beats what you get in most other places. So that is, it's always a pleasure to come here and try the variety of food that is available here. Let me jump right into it. I don't have too much time, and the topic is a bit vast. So I want to sort of focus on rethinking energy transitions, because there are words that have been used in the vision document, and they have become part of regular vocabulary, not just in Kerala, across India as well. Transitions is one thing, but we need to define what we are transitioning from and what we are transitioning into. Decarbonization is another such word, and I want to sort of break down what we mean by some of these things a little bit before I go. So this is a broad plan. I want to speak about whether we focus on decarbonization or low carbon development. There's a certain context in which the term decarbonization is used, whether that context fits India and whether it fits Kerala, even more so, is something that we must look at critically before we use the term in the context of Kerala. The role of electricity, of course, when we speak of energy, especially in Kerala, the focus is almost entirely on electricity. A lot of colleagues from KSEB here, so there is a huge role of electricity in the energy sector, but energy also goes beyond electricity. There are other forms of energy, although the contribution of electricity in total primary energy use in Kerala is particularly high. Resource constraints and energy consumption, I think there is a sort of a common thread across all presentations that focuses on this. And there is some, by the end of my presentation, I want to question some of the assumptions that we make about what we must do to be able to, develop or in plan for 2031. Is it achieving energy sovereignty? That's what the vision document says. What does energy sovereignty mean for a state that is within a country? Is it possible to do something like this for Kerala? Is it even desirable to aspire for something like this for Kerala? Is something that I will focus on. So the first question is, how carbonized are we really? And if you look at, this is coal consumption in 2019. And I'm sorry about the scales there. This is not really to scale, but focus on the numbers. If you look at India, we're the corner there, 13.61. Brazil, of course, uses a lot of oil and gas, so their coal use is low. But otherwise, we have less coal use per capita as compared to developed countries, also compared to many other emerging economies. If you look at per capita oil consumption, you can hardly see India. It's really very tiny barrel there in the corner. Very, very little as compared to a lot of other major economies. And if you look at gas consumption, it's even lower. So all the major fossil fuels, our consumption in per capita terms is lower. And it is important to look at it in per capita terms. It's not absolute numbers really don't tell you the story about what it is. We are a big country. We are 18% of the global population. That means you have to provide services and amenities to 18% of the global population, which means you need to have that kind of infrastructure to be able to do it. And for that, the amount of resources we use is currently very less. It is not something that we must be proud of. We don't use less because we use resources well. Unfortunately, we use less resources because we are poor. And that is a reality that we must confront. So now the next question is, of course, how carbonized is Kerala? When we speak about decarbonization, we must really talk about how carbonized Kerala is. If you look at direct consumption of coal, it is negligible, mostly in the paper and cement industries. Kerala uses a lot of coal indirectly in the electricity sector, imported from outside of the state of Kerala. Does it make sense for Kerala to import coal and do thermal-based power generation within Kerala? Economically, it doesn't make sense for Kerala to do this because transporting coal is far more expensive than transporting electricity. So it just makes sense to generate electricity at the pit head and get the electricity. Although, of course, currently this is being done in a very punishing national regime in the sense that the interstate costs that are being paid by states, not just Kerala, but by all states, are quite high. Oil consumption also fairly less, mostly in the transport and domestic sectors. It's about 3% of all India consumption. If you look at the trends, follow more or less the trends we see in the country, for the country as a whole. LPG is increasing, petrol consumption is increasing, but diesel has more or less stabilized and kerosene has dropped quite significantly. So if you look at energy consumption, India's per capita energy consumption, it's 26 gigajoules. Right? And this is primary energy consumption. This is not just electricity. This includes other direct use of energy as well. The global average is 75 gigajoules. Right? Developed economies are somewhere around over 150, 160. If you take the US, it's about 200 gigajoules. The UK is quite less as compared to the US. It's about 100, 110, but definitely above global average. China is at the global average right now, 75 gigajoules. We are at 26 gigajoules. A whole lot of other South Asian economies as well as African economies are perhaps around the same level or below India's consumption. Per capita electricity consumption is about 1,400, and these are approximate numbers. Of course, they vary based on which data set one uses and whether or not you calculate some kinds of, whether you calculate losses, whether you calculate captive generation, etc. So they vary somewhat, but approximately 1,400. The global average is about 3,300 kilowatt hours, and so that's less than half, around half of less than half of the global average is what India consumes. So in terms of electricity consumption as well, we are very, very low. And 3,300 is global average, like I said. The US is at 14,000 or thereabouts, 14,000 kilowatt hours per person per day, per year. In Kerala, it's about 600 kilowatt hours. So that's half of what India consumes as well on an average basis. Mostly driven by domestic consumption. In Kerala, the load pattern is driven by domestic consumption. That's why you see an evening peak. You don't see a peak in the morning or the middle of the day, like in many other states, even in the southern region, which are where the consumption is driven by either agriculture or industry. So in that sense, at that 600 kilowatt hours or even the 1,400 includes industrial production. It's not just domestic use. It is industrial production, electricity use for services and so on and so forth. So you have all of this included. If you have less of this, then your total electricity consumption is obviously lesser. So what I would argue is that energy growth needed to fuel industrial and infrastructure, energy growth will be needed to fuel infrastructure growth, to fuel industrialization, to fuel modernization in multiple sectors. It is really commendable that despite a very difficult terrain, Kerala has managed to reach 100% universal electrification. But it's not enough to provide electricity connections, and everybody in KSEB knows that very well. You have to deal with growing demands, and those demands are not just there is a tendency sometimes to think of this as conspicuous consumption, luxury consumption. But if you think about basic well-being, what is it that you need electricity for in the house? What is considered today for the working woman, for example, as necessary consumption, it's much higher than some basic lighting and cooling. If we talk about the impacts of climate change with increasing heat stress, cooling becomes almost a right. It's not just something that you aspire to have, but it is something that you would need in the future. Right? So these are things that you must contend with while we think of providing electricity universally, not just providing connections to everybody and minimum amounts of consumption to everyone, but a certain amount of electricity availability at affordable costs to everyone. And of course, a major source of consumption is industry. And so there have to be some sessions, even here perhaps, that have some interconnected discussions in terms of what happens, how are we envisioning industrial growth in Kerala? What is the role of high digital technologies, for example, in the future? What kinds of industries? Are there industries in the energy sector that provide some kinds of possibilities? And there has been a lot of discussion, even in the context of multiple roadmaps that have been made for Kerala, of how the renewable energy sector, for example, provides these opportunities for green jobs and high employment. Unfortunately, that is not true unless you have production across the entire supply chain of the renewable energy technologies. If we manufacture solar panels, if you mine the material that is required for solar panels and build the solar panels and use the electricity and maintain the panels, then you would have enough employment to be able to offset the employment in the coal sector. Otherwise, you actually do not. A lot of the employment factors that are estimated for solar are heavily exaggerated because they include all kinds of other aspects which are not necessarily directly comparable. So, for example, even in Kerala, the grid-connected solar parks that we have, a lot of the jobs are seasonal. For example, you need people for grass cutting during just after the monsoon, but otherwise you don't need people, right? You don't need people for cleaning panels like you would need in northern Karnataka, for example. So in different regions, you require the job creation in the renewable energy sector varies quite widely, but what is universal across all regions is that skilled job creation is actually very low if all you're focused on is operating the plant. If you're not manufacturing the panel, it becomes very difficult to create skilled employment in this sector. Let me, I'm running out of time, so let me move quickly now. What I wanted to focus on was where are the resources, how much of the resources are in Kerala, and we all know, of course, that there isn't any coal, there isn't any oil or gas in Kerala. If you look at renewable energy potentials, and of course, these values are contested. It depends on how much land availability you have. The 12 gigawatt estimate, for example, assumes a whole lot of land that is available, which is really not true in the case of Kerala. But even with that, it is less than 1% of the all India potential. Wind potential is also less than 1%. However, hydro, both large and small hydro, are non-trivial contributors to the all India level in terms of potentials. But the question is, it's not just geographic potential that determines whether a state is ready or not to absorb renewable energy or even to generate it. You need to account for a whole lot of other systemic factors, right? So there's an approach that we are trying to build is looking at generation readiness index and a consumption readiness index, looking at whether or not states across the country are ready to be able to generate renewable energy and are also ready to be able to absorb renewable energy. And these are two separate things. They're not the same. Those who have high capacity of generation need not be able to absorb all of that renewable energy. And that is what I meant by saying that given that we are a country of diverse resources in various regions, there is no reason for us to aspire to develop everything within one region. Where there is hydro, we must exploit hydro. Where there is solar, we must exploit solar. Where there is coal, that is the only place you can actually mine coal. There is nowhere else that you can do it, right? But the fact that these resources are diversely distributed across the country also allows for differentiated ways of generating electricity across the country. And the load pattern, the way in which we consume electricity is also different. Agricultural loads are high in some regions. In other regions, service sector consumes more. In Kerala, it is the domestic sector. In some other states, it is the industry, allowing for a flatter baseline curve. So can we exploit that aspect of diversity instead of thinking about it simply as what should each state do, or competing with states, with other states for resources and, also in terms of prices and bids. So if you look at Kerala, the generation readiness is only slightly above national average. Consumption readiness is slightly below national average, also because Kerala has lower agricultural load, very little load that can be shifted in the day. You have a lot of it being seen by the grid in the evening. You cannot really shift that load. People need electricity, need to put on the light when they need to put on the light. You can't tell them, don't put on the light in the evening, put it on in the afternoon instead. It doesn't work. So you have very little load that you can shift. And so that is why you see this. But if you look at what Kerala has actually done, its deployment is in surplus. There's a 7% surplus in terms of deployment. It's doing more than what its score suggests it should. But in terms of consumption, it is lower. It's consuming less than what its score suggests it should. So is the focus on within state deployment really necessary? Or should the state think of innovative ways in which you can build contracts, build agreements across states to be able to meet this kind of a requirement? And of course, let me sort of towards the end come to the role of hydro. It is an important resource. There is anybody who speaks about either energy or water in Kerala cannot not talk about the hydro projects. There are multiple of them are multi-purpose projects, but the hydro power section of Kerala's power sector is something that even the regional dispatch the regional load dispatch centers love very much. You see, you take the Idukki power plant, you take just like Sheravati in Karnataka, for example, load dispatchers love it because if you have high fluctuations and high variability, there are no other plants that can actually deal with something like this so well. So you have this. Can this be leveraged, in the larger, in the way in which we develop over the next 5 or 6 years? Can these resources be leveraged, both legacy hydro as well as the possibility of new pumped storage plants, for example? Because this also would mean that more renewable energy integration would become possible, not just within Kerala, but within, let's say, the southern region as a whole. There are some numbers here for what that would mean for costs and things like that, but I won't go into the details here because I'm running out of time. So what I want to really focus on is this broader message, but I must say that the previous set of numbers was from an optimization exercise we did for the southern region as a whole. This is with the State Load Dispatch Center. But if you look at the numbers for Kerala, and these are numbers for Kerala that have been extracted, the numbers under even when Kerala has to meet the Ministry of Power target of 43% RPO by 2030, the numbers look very close to Kerala's resource adequacy plan, actually. So there is something to think about in terms of, how this would go. There is, of course, if you look at what would be the cheapest way to go, and providing affordable electricity is necessary, the model, any model you do, will zero on to additional coal instead of solar plus battery. Because if you keep adding solar, you are going to at some point need storage. Without pumped storage, you're going to need more expensive battery storage. But if you have an option along with coal, then the model will always sort of default on coal, even if it is imported coal, right? Not coal that is generated within the state of Kerala. So, multiple speakers have already said that Kerala has land constraints. There is also resource constraints. There is no coal, oil, gas, or even solar and wind resource at the scale at which it is available in other sectors. So, what is this? Why is this focus on self-sufficiency really necessary? The entire nature of the power sector as a concurrent sector, the reason is also that you have diverse demand patterns. It's one thing, the challenge for small countries within large regions, Austria, for example, or some countries in Europe, are different because they are independent sovereign nations within larger regions and have limited resources. We have an advantage of the fact that we have a country which is diverse but unified by some common goals in that sense. So we need not necessarily overdo our understanding of self-sufficiency in this case and narrowing it down. Increasing cooperation with all other states would be, in fact, in my opinion, the best route for low carbon development, not just for Kerala, but for all. So if you really want to achieve low carbon development, it is not about whether I switch off my light at home. It is not about whether my society is more efficient or my state is more efficient, but whether or not what we do together. The NDC is for the country. So, it is, I'll finish in 1 minute. So we have to think about it a little differently, in my opinion. And this is just an example of how the fact that Kerala's load looks different as compared to the load of other states in the southern region can help in balancing and integrating more RE, but I don't have time for this. So last slide. In conclusion, the first thing I want to focus on is that we need to rethink the word transitions. The precondition for decarbonization is carbonization. You can only decarbonize if you have carbonized. If you haven't carbonized, there is no decarbonization possible. And in the case of India, not just in the case of Kerala, I would argue that we haven't carbonized, despite the fact that 70% of our electricity comes from coal. There is no oil or gas in India. I mean, oil, of course, we import and use, but that still doesn't mean we have carbonized to think about decarbonization. The transition must focus on improving well-being, energy access, employment, etc. These are all very real, very near challenges. 2031 is 5 years down the road. 5 years down the road, our more immediate challenges are developmental. And these are the ones that we must focus on. We have to rethink pathways to enhance RE integration. We understand, I understand very well that Kerala also has to, the institutions in Kerala, the government of Kerala has to function within the constraints of policies set at the national level. It's not as if it can do things independently. It has to pay the charges. It has to follow orders that are given by government. And I hope both Ravi and Rahul will speak about this after me. But if we are really aspiring for new and different ways of doing things, integrated ways of doing things, then we must also think about how is it that we can build partnerships with other states to strengthen the way in which we can actually go about low carbon development. So I'll stop here. Thank you.
Thank you, Dr. Tejal. Now, we have two more speakers, Sri Ravindra Kadam and Rahul Tongia, followed by a discussion, and then our respected Vishwanath Sinha Saab and Puneet sir are there. They will conclude the session. So now we will break for tea for 10 minutes and reassemble at 4:50. Thank you. We'll resume the session with those who had coffee. Those standing near the table, can you come forward and be seated, please? പുറകിൽ നിൽക്കുന്നവര് മുന്നോട്ട് വരിക. നമുക്ക് സെഷൻ തുടങ്ങണം, എന്നാലേ സമയത്തിന് തീർക്കാൻ പറ്റുള്ളൂ. ഇനി ഡിസ്കഷനും ഒക്കെ ഉള്ളതാണ്. ആൻഡ് പ്ലീസ് ബി സൈലന്റ്. Can you please occupy the seats? We are going to start. Sir. So we are resuming the sessions. Can you please be silent? Please, silence please. Sri Ravindra Kadam is a senior advisor for renewable energy at the Central Electricity Regulatory Commission. His work plays a key role in shaping regulatory frameworks for the country's clean energy transition. I request Sri Ravindra Kadam to make a presentation.
Thank you very much. Good afternoon to all. I hope after this so-called 10 minutes energy break, you are again ready to speak and listen and discuss on energy one more time. And of course, with a very energetic presentation of my earlier speakers, I will try to create the same into in my presentation, hopefully. And I should thank before I start to my previous speaker, because most of the points which he has already mentioned, I'm just going to extrapolate those questions, those issues, which I believe are going to be an important and key issues when we have to achieve the vision document 2031, which has been proposed here by the planning board. At the outset, of course, with all the dignitaries on the dais and all the participants, I thanks a lot to the Kerala Planning Board for inviting me. And I was wondering, basically, to be frank, what I'm going to speak, especially in terms of assuming that they have a limited role in terms of how exactly Kerala has evolved. But over a period of time, whatever I could achieve, whatever I could gather, I just thought I have some 2 or 3 points which I believe can be used as a commentary on this particular vision document, which if the planning board feel appropriate, they can consider. I also, of course, would like to start with one disclaimer that those are the views which I'm going to say in my presentations are my individual views, should not be considered the views of the Central Electricity Regulatory Commissions. I am basically most probably will speak from the kind of a role I generally play in the commissions as a renewable energy advisors, and what are the issues, the interstate issues of RE integrations I have come across, which I believe are going to be helpful when we are actually thinking of so-called the transitions for more greener in the near future. And I think from that point of view, most of the KSAB fellow here would be already quite aware about all those issues and must be also trying to deal those issues in their daily work to address some of those challenges. But I thought it's important, at least while we are talking about this new target, new ambitions, new green future, it's also important to understand the kind of a complexity it comes with this kind of a transition, and how to actually overcome these challenges is at the same time important when we are all talking about our aspirations, our goal in the near future. So with that, I again would also like to thank Planning Board to have this kind of a huge consultative process to come out with kind of a articulative brief summary of what they want to achieve by 2031, which marks the 75th year of the state of Kerala. And I hope that uh, I would like to give the best of all the best for them to actually achieve those which have been envisaged in their documents. So my uh, presentation is broadly going to cover all these three, four or five issues. The bigger issues are the two, of course, the RE integrations, and what are generally the issues which we see, which at least I have come across at the interstate level, and how that at the interstate level grid or the grid at the national level also, we are actually tackling those issues to manage the challenges which have emerged with this so-called green transition. And of course, the issues involved in the transmission planning, the flexibility, which we are discussing as we go more and more solar into our systems, and of course, the kind of a overall scientific approach of resource adequacy to, to optimize our resources in the future to meet our future demand, and of course, the reliability. So just to start with, I think all of us, since are relevant, are aware and are generally from the power sector background. I'm not going to speak much about this slide, but this slide just to give a context that key in terms of install capacity, we have already achieved almost 50% of RE at national level. Of course, we do have a coal install capacity up to 50%. In terms of energy, of course, the coal coal still dominates our energy requirement, but nonetheless, almost 50% of our RE capacity or non-fossil capacity is already been installed. And of course, that has been installed over a period of time. The kind of an aggressive RE targets which we have achieved at the national level, including, of course, the Kerala, which we all know, have been quite impressive. So we have almost have crossed 100 gigawatt of wind and solar at the at national level, and of course different policy and the other regulatory and the state cooperations have been factored in. Even now, as on date, I think the state has larger share of RE installment as compared to the interstate level. The interstate level RE is around 30 to 40 gigawatt, including wind and solar. But as against the states, almost have more than 120 gigawatt of wind and solar capacity, and managing that too. But with that 30 to 40%, 40 gigawatt of RE capacity, 40 gigawatt means 40,000 megawatt of RE capacity at the interstate level. The issues which have emerged recently in the interstate are quite significant, where you at the interstate level, at the national level also, you need a steep need, you have seen or you are looking a steep net demand curves, which have become a very regular phenomena, where you have quite a high requirement of ramping in the evening to meet your ramping requirement when you don't have the solar available into the system. At the same time, you have seen lot of frequency excursions into the system, which actually threatens a little bit on the reliability aspect of our of electricity. At the same time, most of your thermal fleets have been backed down because of allowing the kind of a allowing kind of a must-run status, ensuring the must-run status for the renewables at the interstate level, and that kind of a extra generation during the peak hours, there has been a sustained frequency, high frequency events, which has become a kind of a regular phenomena in the system. So just a little bit kind technical slides I would like to just highlight. As I was mentioning, at interstate level, if you actually go into kind of a duck curve or a net demand curve, which basically nothing but a total demand curve minus the RE generation at that particular point, gives you a net curves to actually highlight how in the solar hours, if you see the blue lines here, which basically represent the net load curve as against the total load curve of which is represented by the red lines. So you see at the national level, of course, it is different for the Kerala, where the peak is actually now started occurring in the day period. In the solar hours, you actually have a peak as compared to the higher peak. I mean, of course, there is a second peak in the evening too. But in the solar hour, the day hour, at least you have solar generations available in the system. And being a must-run solar generation, you are actually putting all the thermal generators available at the interstate level to their technical minimum, 55% or the below 55%, few for some thermal fleet also, which is basically to make sure that you have more and more absorption of solar during that time. And even after, so the cases have increased so much that even a pit head thermal generator, which most probably the cheapest source available into the systems, are still been asked to back down to their technical minimum to manage more and more solar. Of course, that solar contract can be anything, but or the cost of that solar might be higher, but still, because of a must-run status, we generally prefer to absorb more and more solar into the systems at the cost of even backing down the thermal generator. Of course, that has an impact on the thermal overall fleet in terms of high heat rate, in terms of the efficiency, and of course, sometimes also the life of that thermal fleets. And that has become a very regular phenomena in the systems at the interstate level. And that's why when you have high solar in the day hours and backing down of those thermal generators, but you cannot shut down that generator. That was another option the system operator could have actually thought of, to shut down that thermal generator. But since you don't have enough capacity in the evening to meet the evening peak, then you have to keep those thermal generators running on bar to actually meet in the evening period. And that's why I have created a kind of a thermal generators which is almost running at their technical minimum in the day hour. Have been ramping up quite high in the evening to manage the evening peak when you don't have the solar. And that has created another kind of a responsibility to the thermal fleet, which has been planned for the as a base load, now to also meet the kind of a ramping requirement to the systems and to make it flexible enough to manage that grade. And that kind of a phenomena, as I was mentioning, has become a quite significant. Another phenomena which has been observed recently is that you were expecting that there will be some kind of a demand increase in the demand in the last 2-3 years, as you have planned 3 or 4 years before. But eventually, actually, you don't have that much of increase in the demand, but you have an increase in the generation, and that too, a generation with a zero marginal cost generator like wind and solar, which have a must-run status. So you are responsible to add or absorb as much as power of solar and wind, even at the cost sometimes when you have the high frequency in the solar hours. So even the high frequency phenomena in the solar hours have increased significantly, and that has actually also resulted into some kind of a curtailment, or I would say a deployment of ancillary resource through the renewable energy, where the renewable energy have been asked to even back down certain days. Almost 12,000 megawatt of RE capacity is being backing down regularly in the interstate level. And of course, with these are challenges are happening with 50 gigawatt of capacity. Remember, of course, the state has almost more than 100 gigawatt of RE capacity and then still been managing, of course, with certain kind of a challenges. At the same time, another issue, an important issue is going to be that because you have, it's the current status, but it's not like that it's going to resolve or solve as we increase our energy demand, because with increase in the energy demand you are also going to increase your generation capacity, and the kind of a target which we have by 2030, a target of even 500 gigawatt for that matter, which include almost 300 gigawatt of solar and 100 gigawatt of wind. I don't know how much of that will be achievable, but at the same, nonetheless, those RE capacity addition is going to take place by 2030, and that means you have more and more the intermittent source like wind and solar. The only another characteristics of the solar is that all the solar happens at the time when you actually may not be requiring that much of energy, but your all the generation from solar is going to happen in the solar hour. That means the value addition with the additional capacity of solar is going to reduce with day by day if we don't have a kind of another flexible resources into the systems to actually absorb further solar capacity into the systems. And that has also another possibility or element, especially for the Kerala, which becomes, I think, an important aspect, because Kerala, as mentioned in the vision document, still has a dependency of almost 70% on the import dependency, or at least the interstate import of coal and other resources are around 70% of the total procurement of Kerala. And if that is the case, the transmission charges at the interstate are going to play an important role in the near future for the state of Kerala. And I think the kind of a trend which you see at the interstate level, the transmission charges are actually being increasing over a period of time. It's actually now from 50 paise to almost 93 paise on an average basis. Of course, the Kerala plays another important role by actually absorbing a lot of waiver burden given at the interstate level to the wind and solars, because at the interstate level you have a waiver, transmission charges waiver announced by the central government for those wind and solar transmission of wind and solar, but actually it has been socialized on the other consumer. I think the Kerala is also the one of the entity who is actually bearing the burden of that transmission waiver, which actually runs in a which actually quite a significant as compared to the other states, and especially because the Kerala has a lot of non-fossil kind of a procurement outside the states. The burden of that transmission waiver in this on the state of Kerala is quite high. I could not come out with the numbers, but those numbers are quite significant, and I think most of the KSAB in their regulatory submissions have always highlighted this. So I thought I will not come with the numbers, but at least once again I highlight that one issue, which again I think is going to become critical by 2030, and to make a much more optimization or cost benefit choices, which as a Kerala are thinking over a period of time. At the same time, I think the kind of a transmission planning which has been envisaged at the interstate level will also have an impact to some extent on all states, and of course including the state, whether allowing more absorption of RE through HVDC or the LVDC at the interstate level will also going to have a burden overall, because at the end of it, all the costs in the power sectors are generally being covered by the consumers and eventually the state and eventually by the consumers, and that requires a kind of a much more scientific management of your resources in the coming year. And I think Kerala in this vision documents should emphasize a little bit more on those kind of a optimum resource mix, which has been covered there, but it's not been that elaborative how exactly you want to go ahead with it. Because even the kind of a resource adequacy plan submitted by the KSEB to the Kerala State Electricity Regulatory Commissions have a lot of lacuna in terms of how scientific is that plan is, how much actually we are going ahead with respect to the vision which we are expecting, and with respect to the kind of challenges we have in the coming days for actually going to such kind of a transition, a much more just transition as compared to the for just a transition for the sake of it. And I think that is an important aspect which as a state of Kerala and as vision documents need to look into. And of course, that requires the kind of a flexibility available, the flexibility available into the system, not only within the state, but even the outside the states. And that flexibility need to be, I would say, explore further with much more scientific approach, because I can understand there are limited resource availability in the state of Kerala, but still, even that within that, I think there are certain advantages to certain technology Kerala can think of. For example, a PSP, off-river kind of a PSP, which is actually another new, not new in that sense, because in the state of West Bengal, I think the left government there had actually commissioned a 900 megawatt of Purulia PSP projects in 2007, and it has become a kind of a darling for that, darling project for the load dispatch centers and the state of West Bengal, where actually most of the losses have been covered by that PSP available at the hand of the discoms there. And I think being the off-river PSP projects where you don't have actually too much of an environmental impact, that has become actually quite a source for the employment in the state of West Bengal also. And something like that, I would suggest the state of Kerala also can think, which requires a little minimum environmental concerns. At the same time, I think that's why my last point on the vision document, as a sort of a comment on the vision document, is actually how scientific our resource adequacy is going to be the key questions. And I think there has already some efforts going on at the state level. I have been told that the so-called indigenous model of Stellar has also been given to the state of KSAB to actually train the capabilities of their of their officers to run that kind of an optimization model, which hopefully will be much more scientific as compared to generally the kind of a model which we use based on our historical extrapolation of the demand and the supply. And I hope basically that need of resource adequacy is going to be critical in the coming days, and the state of Kerala will actually try to use all these issues as part of a kind of part of a challenge to address that resource adequacy in the coming future. And from that perspective, I think that assessment of the state, assessment of the demand in the coming futures with new and innovative load and technology, whether it's a data center, whether it's EV load, or whether it is a distributed renewable energy source, I think they are going to change a lot of dynamic of a distribution company, where distribution company, which is generally been trained to look into a one directional supply, is now also now look into the bi-directional supply, and also be ready with the kind of a challenges it will create by allowing such kind of a bi-directional supply. In that, I think the kind of a pilot which has been implemented in the state and for the vehicle to grid is also going to be a challenging and quite innovative, which eventually will have a lot of changes in the way you used to think how the demand will increase. Your demand actually quite changed quite significantly with such kind of a new technology, and that has to be taken into consideration when we are thinking of resource adequacy as a larger picture. Another point, which is static versus dynamic. Is like generally with this kind of a new innovative technology and the kind of a new challenges, you might have a different kind of a scenarios which you might not have envisaged in earlier. You might have actually quite a stress period at completely different period of time. Let's say there are some certain times, certain optimization model do talk about the solar and wind integration and do to meet the requirement, future requirement. But many times, if you have more than 2 or 3 days of non-availability of solar, then how exactly the system is going to work? How the stress scenario at that particular time is going to work out to make sure that you ensure the quality and reliable supply to all your consumer is going to be a question, and that kind of a scenario building also has to be a part of your resource advocacy to understand, highlight those stress period where you can actually not only think from a deterministic point of view, but a kind of a probabilistic point of view, what could be the different possible scenario, and sensitivity analysis can help me to make sure I have a reliable supply in the near future too. Of course, it comes with the resource diversity, and of course allowing kind of a sharing of resources. As my earlier speaker said, if the cost economics is difficult to actually develop certain resources in the states, are there a possibility of sharing those resources with your neighboring states or the other states, has to be explored to understand, to make sure that the overall optimization of the resources are generally affordable and allow as a state, as a Kerala state, to achieve the growth or the development which they actually require significantly. So with this 2 points, I will stop my presentation. Thank you very much.
Thank you, Dr. Kadam, for that speech. And Dr. Rahul Tongia is a senior fellow at the Center for Social and Economic Progress. His work spans energy and electricity systems with a focus on renewable energy, smart grids, and energy sector reforms and pricing. I request Dr. Rahul Tongia to give the address.
Thank you. And we started this session post-lunch with sort of the sugar implications of food, but then it should have been tea and coffee and caffeine. But I think this is an important topic that we're grappling with, which doesn't have an easy answer or a simple answer. So I want to try and pose some questions to you, not to try and wake you up necessarily. So, as a scholar, I want to just ask, how many here have an electric vehicle? A handful of hands have gone up on it, 10 roughly. None from the panel, from this stage. How many of you bought that vehicle because you wanted to be green? Okay, good fraction of you. Hold that thought, and we will come back to it when we sort of think about, when we look at this vision of 2031, it's a journey, and things will need to change from what we are doing today to how we set up the right frameworks for the answers tomorrow. So my work really tries to unpack, how do we move beyond targets, which can be guidance, to really enabling frameworks so that individuals, states, citizens can really make better choices where the individual and collective might align. So this is really the fundamental issue towards energy policy, but also sustainability overall. What is your objective function? Some of you may have heard this term, energy trilemma, where it's really about, how do I balance cost, sustainability, and security? So it's multiple objectives, sometimes with a trade-off. But it's more than just these three. I think we want many more. We want social equity. We want consumer choice. We may want jobs. So make in India, even if it's a little bit costlier, gives you resilience. These are some of the trade-off questions at a design level we have to be transparent about. At a rhetorical level, I would ask a very rude question. If renewables were so cheap that we don't need fossil fuels as a country, Kerala, of course, has limited coal-based power within its borders. Then if it's so cheap, why do I need an RPO or RCO, renewable consumption obligation, that has been put out, as Tejal pointed out, the 43% at a national level? Because the devil is in the details, and that's a few of the points I wanted to share based on studies we have done at Central and other states. I will observe, when we talk about objectives, I'm very impressed with the vision document, because it's not a decarbonization document. It's not even an energy policy document. It's, in fact, listing 34 different sectors. So it's a societal document. And that's really how you should, I believe, think about energy policy, decarbonization trajectories, etc. In economics, there's a fancy word or term used called fallacy of misplaced concreteness. What that essentially means is you measure one thing and you think you're getting information on something else. So GDP is probably the most used and abused metric that people aim for. And Kerala's per capita GDP, in fact, has been steadily growing. It's now one of the higher in the country. But by far, as we had seen earlier today, it had outpaced GDP per se as the marker when you look at Human Development Index, or as we heard in the morning sessions, Sustainable Development Goals, SDGs. So now coming to this intersection of energy and a little bit about water. As we know, Tejal had pointed out some numbers. In Kerala, the dominant electricity form is hydropower. No major coal plants within the boundary. Now, when you dig into the data, I looked at the last 6 years. Hydropower is a wonderful resource. Do we have enough to go 5x? So if maybe 10x? So if Kerala's per capita consumption is in the order of 600 kilowatt hours, plus or minus, and you think it needs to be at the plateau, couple of thousand at least. We don't necessarily have to be what the US was, but a couple of thousand is not only expected, but desirable. Will hydro resources scale? And the large hydro projects are not growing. We have water management challenges of fresh water already, and land availability is a well-known sort of challenge. Now we throw in climate change and variability. The plant load factor or capacity factor of hydro across Kerala in the last 6 years has varied from about 31% to almost 50%. So that means on a good year, good quote unquote, you will get more output, but what do you do on a bad year? So in the planning term, I fully second what Tejal had pointed out. Kerala has to do its internal plans, but also think about how it integrates with the rest of India. So the first sort of point is, when we think about planning, is uncertainty is probably the single biggest thing to think about for planners and policymakers. Now, uncertainty to some people translates as risk. So who pays for that? Or risk management? That's another question. You can always oversize and over-engineer, but I would suggest we should not treat this journey as a supply-side problem. In the old days, the electricity grid was largely firm and dispatchable. You get power when you ask the generator to give it to you. Now, as renewables grows, your supply is volatile, well known. Ravi talked about that. So what's the traditional solution? It has been to oversize supply to handle that volatility. I think Kerala can be a pioneer, and the vision document talks about it, that we should think about a smarter system where not only is it a supply side solutions, but we also look for demand flexibility and demand smartness. That can be cheaper than just over-engineering on the supply side. A second observation on this state boundary issues. We have to do better accounting, and this is true for all energy. For those of you who track this, you may have seen EU just in December announce new notifications for all exports. When you say I have electricity embedded into my fridge, my steel, anything that I'm selling, the car, they will ask, what is your hourly emissions profile of the electricity you are using? So this is the next journey that we need. If I could leave you with one thought, it is that whatever we have done as a country and as Kerala has been round one or step one, stage one. We need to plan now for rounds 2 and 3, where firmness, hourly, etc. matter. Most of you will know and maybe have visited Kochi Airport. What is the moniker you think of from Kochi Airport from an energy perspective? Solar, yes. World's first 100% solar airport. That is the plaque. They have lots of solar panels. Empty spaces, parking lots, runway sides. Brilliant. Do they have any batteries? No. So how are they 100% solar? By over-generating solar in the day, giving to KSEBL, and taking it back at night, which is an accounting offset. And in stage 2 of the planning, decarbonization, and transition journey and energy security, it's not just about lowering carbon, but about energy security. We'll have to think, can this scale? Because KSEB is managing the costs of that shifting and worrying about how do I procure in that evening peak, which is still a challenge from a net demand perspective. Net demand or net load being your demand after removing what RE gives you. Middle of the day, India is peaking. Solar is great, but we still have a secondary peak, morning and evening. So your net demand in the curve that Ravi had shown, you could see those humps in the morning and evening. So we have to move towards more sophisticated accounting and planning. This is exactly why KSEB has asked the regulator that can we put a pause or an update to net metering for rooftop solar. Kerala has been a high achiever of stage 1, where we encourage people to put rooftop solar. But that same rooftop solar under net metering gets to take their excess solar power in the day, give it to the DISCOM, and offset it into their bill. So that's a challenge from a financial perspective and a grid security perspective. So ultimately, we have 3 transitions. It's not just decarbonization, but also decentralization and digitalization. All of these put together are going to be the change that we have to plan for. There are 3 main lessons I would suggest from other countries and in India. The first, we have to regulate better. This is not just a supply side problem. We have to move from a costs plus centralized world to one that inherently has volatility, where you can have edge-based transactions. I'm part of the government's task force on India Energy Stack, the digital electricity transformation. And eventually, you will be able to take your rooftop solar and directly send to a third party, maybe even in another state anywhere. Now, whether that electron actually makes it all the way across India is irrelevant. On an accounting level, that is being enabled through the, or will be enabled through something like the India Energy Stack. But What does that do towards discoms? Who bears the risk? Who becomes the provider of last resort as you have new entrants come in under alternative supply modes, not just competition? We have to now worry about time of day, which is the single biggest shift as we think about electricity planning, energy planning. It's not enough to say, I save electricity. Yes, we should. But I want to make sure we save it at the right time and the right place as well. And those incentives are not quite there with the consumers. Now, obviously, for the small consumers, you will need a digital meter, maybe a smart meter. KSEB is, of course, moving towards that, but it will take time. But we start with wholesale. Second, we have to worry about winners and losers. As we have any energy policy, it's not just decarbonization, any change will create some people better off, some people worse off. So when we modeled time of day pricing based on high solar, because that's the national picture, we are surplus or close to surplus many parts of the midday. Make power cheap midday. Correspondingly, you have to make it costlier at night. If you do that, households will have to pay more compared to, for example, single shift industry or commercial users, because household consumption is disproportionately morning and evening. This is the winners and losers that we have to think through. And last, we need to innovate. We need to have new mechanisms of incentives for consumers, because what I'm really impressed by with this exercise of the vision documents is this needs to be a conversation on what do I value, who can, who should, and who's willing to best pay for all of these risks. The climate change has been called a wicked problem. In public policy, that's a problem space where it's not about right or wrong. There are trade-offs to be made. And you cannot solve a wicked problem through optimization. Any engineer who tells you that, they're not putting all the variables inside that equation. The human side has been missing. So we have going forward a state that's rich in many resources, maybe not fossil fuels, but the biggest resource I think Kerala has to exploit, to harness, is the people. That future will need to be a dynamic, nimble, and smarter grid. And that's where Kerala can innovate. It's part of the vision document as well. So I'm delighted to be here to share some thoughts and be part of this journey. Thank you.
Thank you, Dr. Rahul Tongia, for that insightful speech. We have got only 20 minutes left to close the session. 5 minutes, we'll discuss the topics. So I have requested my colleague to circulate the mic. 2 mics will be circulated. So ask pinpointed questions to whom you want to ask, to who should answer it, say clearly. We can allow 2-3 questions, very important 2-3 questions to be answered by the experts. Can you pass on the mic?
Sir, thank you very much for the beautiful presentations. I have a question related to water resources sector. I'm just asking one question. Actually, I have 2 questions, but I specifically want to ask this to James, sir. You rightly pointed out that the integrated water resource management should be the paradigm shift that should happen in Kerala as a part of the Vision 2031. That's true, sir, but now we have already conceived this idea and it is reflected in our document. Now, what is your viewpoint about the institutional arrangement that we should have for implementing this integrated water resource management in Kerala? Because right now where we have reached is just we have made an overarching framework for the implementation of IWRM. Do you think this will be sufficient to have the real IWRM in place in the field, like as you were discussing about Mekong Basin or even the Murray-Darling Basin. What is your viewpoint in that, sir?
I'll tell you, the greatest weakness of implementing integrated water resources management in Kerala is the institutional setup. We should have an entirely different institutional setup to have integrated water resources management in the state. When I say this, I have already quoted the example of Mekong
Basin.
River Commission. What I suggest is that if we can have a total commission for all the river basins of Kerala and then have clusters of rivers together to be managed. Because we are talking about intra-basin transfer from the surplus to the deficit. All these things will be possible only if you have an integrated governance. And governance is very, very important. And most of the developing countries, I don't know whether Kerala is developing or developed, the problem with water resources management is governance. Now, if you ask me examples, you have got the Severn and Trent Authority, you have got the Thames Authority, they're all functioning very well. Way back in 1982, when I was in England, I was taken to Severn and Trent Authority. They were getting information from the river basins. At that time, you never had your internet and IoT and all that. You had telephone, which will give the water level. Immediately, if there is a need, they will say that release water from that lake if there is a quality problem. Or if there is a quantity problem, where you have got excess water, you release water from that to meet the requirements there. This is a system which we should have in Kerala if we want to efficiently manage the water resources of the state.
Thank you, James.
Now, apart from this, one more thing, this is about governance and institutional mechanisms, I said. Where we lack is Kerala, I don't want to say is fragile, it is fragile. Because if we touch a small river somewhere, it is going to have its impact downstream or upstream or anywhere. So, when we deal with Kerala, we should have proper environmental considerations. Why I'm saying this, I'll tell you. The estuarine systems of Kerala, the wetlands of Kerala downstream, are often deprived of the required quantum of water from upstream because we don't have a proper operation policy. I'm not saying that we should not have dams and all that. We can have all that. But we should have a scientific operation policy, which was lacking, which was proved during the last flood time. I think this was known to us that with little more, with the better operation, maybe 30% of our flood levels should have been brought down. I'm not saying 100%. It's act of God. We have no control over it.
Thank you, sir.
Yeah, that's all what I wanted to
We'll
say.
move on to
Thank you. Yeah.
I think we are overshooting our targets. If you have further questions, kindly write to us or give it in writing. We'll get the answer in your mail. Kindly write your email or phone number below the write-up. So now it's time for summarizing, we have got two senior bureaucrats at the ACS level. Vishwanath Sinha sir, a person who has got in-depth scientific knowledge in matters related to water. He combines able policy conclusions, technical feasibility and financial viability while taking decisions. I request Vishwanath Sinha sir to conclude. Puneet sir.
Yeah.
Puneet sir always goes into the depths of the problem. Both of them were former member secretaries and planning secretaries, and has contributed to policy decisions. So as decided, I request Puneet sir to offer his comments.
Good evening, everyone. It's indeed very difficult task to sum up such kind of extensive and intensive discussions on the very critical subjects of water and power. If at all, I can say this is slightly out of context, but if I can say that, in the next decade of landscape of development, the entire script will be around water, power, and data. These three items will occupy more attention, more research, more discussions, and how to use it. Some of the friends who spoke about various issues, I'll very quickly try to summarize. The moderator, Dr. Ravi Raman, set the tone in which this Vision 2031 is to be discussed for state of Kerala, and what all state of Kerala has done in the fields of water management, power. I'm not saying that we have done a lot. Perhaps there are more challenges and more to do in the times to come, and that is why we have all assembled here and we are mulling our minds. Dr. Gosai stressed on the importance of the renewables, including the hydropower of Kerala, use of the nanobubble technology. Yes, we need to rely more upon that, and perhaps we need the dialogue with the industry and academia for such kind of research in the water management, in the kind of power, and especially focus on the RE. Honorable Prime Minister has also laid a very clear roadmap as to how we have to go carbon neutral by 2070. Professor James, who is an authority on the water management subject, mentioned about the integrated water management, harnessing rivers for the hydel power, and how most of the rivers in Kerala are stressed and they should not be overexploited unless they further kill the system downstream lakes and the wetlands management. Further, Dr. Deepak Vashne explained the proof of concept which was done in Gujarat for solarization. I am personally aware similar work has been done by my batchmate and colleague Lokesh Chandra in Maharashtra. And this has been done through the grid-connected power plants, use of the PM Kusum, etc. Kerala doesn't have that kind of bandwidth. We do not have so much of agriculture. Our consumption of electricity in agriculture sphere is less than 1.3% of our total consumption. Still, we have implemented over 2,500 solar pumps, and while the Gujarat model gives some incentives, etc., we don't give anything, and still we have been able to do that, with the state support and with the support given by the union government. Dr. Tejal Kanitkar made some very thought-provoking observations during her presentation, especially on the issue of how do we decarbonize when we have not even carbonized in the state of Kerala, and how are we aiming at the development, equity, jobs, etc. And she also mentioned about the index framework being developed with the Generation Readiness Index and the Consumption Readiness Index for the renewable capacities. Perhaps these are the issues which have to be looked into more details and the possibility of putting these things into use while we go during our journey for our realizing of the Vision 2031. How we have to manage this transition is going to be a big challenge. Dr. Ravindra Kadam talked about the challenges in the renewable integration with the grid. And since India has already reached 50% of the renewable energy installed capacity, there are many instances of the high frequency events taking place, leading to the curtailment of the solar power plants, which enjoy a must run status. In fact, today only there was a news that Central Electricity Commission has, Regulatory Commission has penalized on delayed projects where in Rajasthan and where the contractor has not been able to complete the project. So perhaps there are issues coming up in the expansion of the renewable energy through the solar and management of the same through the transmission bottlenecks which are coming across the grid. Dr. Rahul Tongia talked about the cost versus security versus environment, competing trade-offs in the energy sector, and Vision 2031 document cannot be seen as talking about energy as a standalone sector. It has to be seen as an intersectoral societal document. Thank you. We really take your point, and the entire focus is also on a holistic development in Kerala. And I would very briefly mention that while all this is going on, Kerala does suffer from various constraints. It has 600 kilometers of coastline. There are coastal regulation zones, which are coastal regulation rules, and we are not able to develop or do the construction as we desire. There is 35% of the land area which is covered under the forest. Getting any new project requires forest and environmental clearances. Again, there are a lot of bottlenecks which come in. Ours is a very densely populated state. We hardly have any land for the additional infrastructure projects, and so for the industry. But yes, whatever is possible, we have still done very good. And we have done a lot of work in the last 10 years by bringing in LNG terminal, which has given a new lease of life to the MSMEs. We have Cochin International Airport Limited, which is completely solar powered, and excess solar power is now being used for the production of the green hydrogen. There is already a pilot project on the green hydrogen, which has just been completed, and it is now waiting only for the formal inauguration. So it is not only the first completely solar powered airport, it is also going to be the first in the globe which is going to generate green hydrogen from the generation of solar power at its own premises. Similarly, there are other 3 airports, a lot of other development which is taking place. Kerala has very huge penetration of the electric vehicles, and we are one of the first states again which has submitted our projects to the Government of India through Ministry of Heavy Industries for creation or rather augmentation of the fast charging infrastructure for the EVs. Our plans for using distributed solar for strengthening the fast charging EV stations is there in place, where we will be consuming a lot of this solar power during the day and bringing in change in the consumption patterns also. We are focusing on improving our hydro projects through pumped storage policy, and perhaps very soon, as Professor James also mentioned, and we were discussing on the sidelines, we have estimates of 3,000 megawatt generation through the pumped storage and the exploitation of the other hydro resources. But yes, at least 1,500 is something like low-hanging fruit. And first 500 megawatt with the help of NHPC has been in the focus, in the limelight, which might be starting very soon with the help of the NHPC. Similarly, there is a 60,000 crore of investment which has been estimated in the next 5 years to strengthen generation, transmission, distribution, storage, and digital systems. Comprehensive end-to-end resource adequacy plan, which is fundamental, has also been put in place alongside demand-side measures such as time of day tariffs, power consumption literacy, which is a very, very important factor and that needs to be taken to the masses. Everybody must understand how to use power, what kind of gadgetry should be used, what kind of appliances should be put in place, what should be the manner in which we can actually reduce our cost. Then only we will be able to make the best and most optimal use of the renewable energy. So, efficiency first, our energy management center is working on various projects and it has shown its pathway. And this is going to be one of the major agency which is going to help us in realizing our Vision 2031, because whatever power is saved or which is cut down from our own consumption requirements is virtual generation for us. So these are few things which is already embedded into our Vision 2031 document with regard to the water, power, etc. And as far as the scientific management is concerned, we are already taking care of many of these aspects, integrating energy, water planning, strengthening hydro flexibility, storage, leveraging data and technology, and coordinating institutions so that our growth remains reliable, affordable, sustainable, and resilient. I would also like to mention that we have taken into account the growth of the new projects which are offering new opportunities, such as Vedinjam Port. Once it comes to the full potential, it will certainly open new vistas for the new MSMEs which will require power, which will require a lot of energy. The data analytic companies would be power guzzlers and they would require a lot of power. So how to do that? We have to act smart. We have to create pumped storage systems which provide resilience, climate resilience, we have to basically ensure that wherever our solar power has been created, solar plants have been created, that is linked to the battery storage. And with the help of our pilot project in Inert, which is doing wonderful job, they have created vehicle to grid pilot projects. Once this comes into picture, my feeling is the Kerala population, which is already very conscious and enlightened, will be using certain different paradigms, such as charging their electric vehicles during the daytime and reducing that much of pressure on the peak power in the night. The daytime power consumption will be used by taking recourse to the fast charging stations powered by distributed solar power from other states. Already, Kerala State Electricity Board has tied up various swap arrangements. So this is how we are going smart and we are leveraging wherever we are growing our renewable energy. So with these few things, I conclude and I look forward that next 5 years, we have a lot of challenges, but yes, with the help of academia, with the help of the research institutions and some of our implementing agencies like Inert and KSEBL, we will be able to meet the challenges which are there looking at us. Thank you.
Thank you, Puneet sir, for your comments. I now welcome Sinha sir, who is the Water Resources ACS.
Distinguished panelists, dear friends, it's 6 p.m. in the evening, exactly. Water as a sector, as a subject, as a governance matter has least priority from the inception of this civilization till date. Yes, we have this subject allocation in the government of every country, every state, every district, every panchayat, in any geography. But nobody and no policy has ever given any space to water. You may disagree with me. I have my colleagues from Water Resource Department sitting here, some from Power Department also. I know them also very well, some of them. If you go and see and check who belongs to which part of water resource, you'll find a segment. My water authority officers are sitting in one place, groundwater other place, irrigation department somewhere else. This is what is the segregation of water resource department. There is a territory concept. This is mine. The most divided subject for administration. Every panchayat has a say in water. It belongs to them. River passing through them, segmental approach. Go below earth. Water is integrated. Governance has broken it. And that is the reason water as a subject of administration in next 5 years or 10 years and more, we have a perspective which is there in our document, which talks more and more, and certainly drawing lines from what Professor Gosai said, what Mr. James said, and what others said. The policy talks about integrated water resource management department very clearly. Last year, we have started the first wheel of institution, which is called River Basin Management Authority, to be coming the picture with a 3-tier structure, state level institution, river basin level, and then panchayat level. But I am little bit differing from when he says it's a societal approach. I call it a suicidal approach. That's the only difference. I have a very big army of officers working in my department. They are bachelor in civil engineering. They're all water holding or water conveying structure engineers. They are not water engineers. This is the army which I have to work. Governance requires a change, and that is what is the aim in next 5 years. Look at the water. We don't bother. I see a lot of documents which you want to change, now we're going to change. What allocation for water resources made? For creation of new structure, repair, maintenance of the structure. It is not meant for whether that structure is any more necessary, whether we really need the structure. People who have been using the structure, are they ready to pay for price of water? Next 5-year policy is going to talk about, and very clearly, pay for water. Yes, water is a fundamental right, limited to safe drinking quality water. Beyond that, use of water requires to be paid for itself. What is crying for itself now? Whether this state or the other state. Kerala government policy doesn't talk about interstate transfer, international transfer. Water cannot be transferred. It will flow in river basin from origin till destination. It's an ecosystem approach. The Dublin document talks about blue water, green water. Water is water, obviously in every form of only green. Water needs price to be paid for. My groundwater authority, it's a very set of administrators. They have a policy of permitting or regulating use of groundwater. Groundwater and surface water, there is a clear-cut relationship. When inter-surface transfer takes place depending on 3,000 mm of water in Kerala. Where is this water going? Are we really going to ask the people that come? Policy is going to help the water to pass through rural area, urban people polluting it more, industries are polluting it more. Pay for it. Ecological flow of water is a prime serious policy instrument in times to come. River basin approach is going to be the primary objective of every stakeholder. My chief engineers and engineers are going to only guide them technically. It will remain the mandate of the people in the policies. The biggest problem of the water resource management is that it is nobody's baby that we propose to break in next 5 to 10 years. It has to become everybody's baby because this will be a subject in times to come. Most occupied or repeated words in the disaster management plan over years. So better, the government has a clear-cut policy towards taking water administration and governance to the real stakeholder. And that is going to happen with the most important thing. All our colleagues spoke about, I think somebody spoke with detail about carbonization. The entire world talks about carbon credit. This government is going to talk about the water credit in next 10 years. You are using the water, engage yourself in activity which generate water. Take the credit, trade it off. Some people will know more, some people will less all. The basic administration paper which is with the government, which is the Kerala State Water Policy 2025, a draft stage, talks about the water tradable credit system. I think 6 o'clock, 5 minutes is more than enough for me to tell you what is there in policy of Kerala government. Kerala State Water Policy 2024 is the website which tells about water administration and governance for next 25 years, 2047. We welcome all your comment. We strive towards making water better for you, not you becoming better for water. Thank you very much.
Now we are entering the concluding session. I request the moderator's remarks. 2 minutes, sir.
Frankly, I'm a bit optimistic about the way in which we function in Kerala with respect to the utilization of these two critical resources. I just got a line from my research assistant. As of August 31, 2025, more than 70% of Kerala's population is covered by piped water supply, including public taps under the Kerala Water Authority. I think it's a big progress, I would say, because I know the earlier figure, which I don't want to quote because I'm not 100% sure, but over the years, this has been improved. And coming to the institutions that Professor James has raised, that is true. That's a question everywhere. It's nothing to do with the Kerala alone. Everywhere, in advanced countries also, you have institutional constraints. And at the moment, I tell you that you have 3 or 4 major institutions taking into account how best we could plan the water resources. We have this CWRDM. James was a major player of CWRDM. Director? Yeah. So you are the director of that, and they do wonderful research, hydrological research, all kinds of such research, groundwater assessment, water quality monitoring. Yeah, so that institution is very powerful in Kerala. They do a whole lot of work. And at community level, you might have noticed that we have Harida Kerala Mission, which promotes water conservation through rejuvenation of ponds, streams, rainwater harvesting, wetland protection, preparation of water budgets, and like that, And apart from that, the irrigation department that you have mentioned and Kerala Water Authority. So I would say that, look, we are reasonably good, in terms of the performance of the existing institutions of water resources of Kerala. But obviously, we will have to improve it. Coming to the energy, of course, we have already mentioned that we have realized this 100% what is called electrification of households, and we have also we have also improved what is called the sources of non-fossil fuel energy resources. And one of the critical questions, perhaps missing in the whole debate, is that what exactly is the case with respect to the government of India's attitude towards higher and higher levels of privatization of energy in India. It is not just a public resource anymore. It's not so. It is increasingly being controlled by the monopoly Indian big capital in India. And they also legitimize the way in which it is being privatized. So perhaps one of the critical issues that remained unaddressed in the whole discussion is something to do with who actually controls this critical resource and like that. That's an issue which is being missed. Of course, Rahul had raised the point that trilemma, and that's what we are obviously engaging with. The security question, the what is called the affordability question, and the sustainability question, and like that. We have wonderful institutions like Harikumar is there, for instance, the Energy Management Center in Kerala. And I don't think that you have parallel sort of institutions in other states in India. We have, and they do wonderful work, how best you could scientifically manage the power resources in Kerala and like that. And we also have NERT, for instance, they also do wonderful jobs. So I tell you frankly that we are very good at the moment, but that doesn't mean that this is a final phase of our progress. That is specifically why that we were hearing you patiently, and we got a whole lot of ideas. I mean, we all know that we are planning to go for what's called the knowledge economy, which is nothing less than an epistemic shift in terms of knowledge, where I am sure that we would be able to accommodate most of the critical comments, most of the critical reflections that you have made. Thank you so much.
Thank you, sir. Now I'm here to propose the vote of thanks. We had with us today, rather we are elated to see the experts and bureaucrats coming together to discuss the way forward towards a brighter vision 2031 for Kerala. I thank Dr. A.K. Gosain, Professor Emeritus, Department of Civil Engineering, IIT Delhi, for coming over to share your thoughts, sir. Thank you very much. Now I thank Professor E.J. James, Pro Vice Chancellor, Karunya University. Personally also I am thankful to sir because I took over as Chief of Agriculture Division in 2018. Since that time, he has been associated with Kerala State Planning Board and state's planning process in water sector. Thank you very much for coming, sir. I thank Dr. Deepak Varshni, IWMI India, for his insights shared with us. I thank Dr. Tejal Kanitkar, Associate Professor, IJIDR. Dr. Tejal was, I think during COVID time, Kerala looks beyond. You had given us your thoughts on this, on the same topic. So thank you, Dr. Tejal. I thank Dr. Ravindra Kadam, Senior Advisor, CERC, for his insightful talk. I also thank Rahul Tongia, Senior Fellow, for it was a very, I can say that it was thoughtful, but you have put so many brighter ideas in a very lucid manner. Thank you very much, sir. And we have with us two very senior bureaucrats, Vishwanath Sinha sir, who is the Additional Chief Secretary, Water Resource Department, and Sri Punit Kumar IAS sir, Additional Chief Secretary, Power. As I told, both of them were Planning Board and Member Secretaries. Actually, Punit sir has helped us a lot in arranging various facilities because he had helped us, and rather he is the force behind getting so many national and international confirmations for this conference through his efforts. Thank you very much, sir. Sinner has always told us that he has asked a question. He had asked a question that the same water which you used to drink, you use it for your flushing the toilet also. Is it the right way to treat water? Like we say, the concept, we propose the concept of one health. Now he is proposing to us on water. Thank you very much for your leadership, sir. And we have today with us Dr. T. Jayaraman, former member, State Planning Board, Minhaj Alam IAS, ACS, sir was here. And we have with us Sri P.B. Nuh, IAS, and Sri Harshil Kumar Meena, IAS, Sri Paul Van Mil, and various senior officials of the state agencies. We profoundly thank each one of you for coming over and making this a lively discussion. And last, not the least, the session committees, especially my staff from Planning Board, Hasija, Shibu, Salam, Ruba, and the supporting staff from Kerala State Planning Board, and also the crew team, SIDIT, and all those people who has made this occasion a meaningful one. With the permission, with your permission, the permission of the dais, I close this session. Thank you very much. Sir. No. Kindly stay back. We have to gift our no issues.